we're going to talk about functions and all the wonderful stuff about functions. So first thing we need to discuss is if it is a function. So first thing, let's go by graph. Let's talk about it from graph perspective. In order to decide if something is a function from a graph, we use the vertical line test. And I can't spell. Vertical line test. The vertical line test says that on a graph, if I draw a line straight down and it crosses the graph in more than one spot, it is not a function. So using the vertical line test, if I have a graph that does this, and I were to draw multiple lines straight down and it only crosses at any of these spots in one place, then this is yes, it is a function. If I had a graph, let's say like this, and I were to draw vertical lines down, and it crosses in more than one place, so you can see it crosses in 1, 2, 3 spots, this would be no, it is not a function. That is the vertical line test. Sometimes we call it the pencil test because we can take our pencil and go right over top of it, and a pencil usually is a vertical line. Okay? Usually, right? All right. So the other way we look at it is from the numbers. So let's say from a table. In a table, it is a function if only 1x for every y value. So let's say I have it in a table. I'm going to put a table up here. And here are my x values. And here are my y values. Let's go. Let's say 2 goes to 8, 3 goes to 7, 3 also goes to 9, and 4 goes to 10. If you look at a table and one of our x values has 2 different y's instead of just 1, then this is not a function. However, if in our table I have 2 y's to the x value, that's fine. So every x value has its own y, right? So this would be yes. This is a function because none of the x values repeat. We used to say that if you looked at all your x values and none of them repeated, then you can say yes, it's a function. All right, so real quick, when we have a table, start with that. The left-hand side is our x value. The right-hand side is our y value. We have other words we use for x. Right? We can call this side the input, which means if that's the input, this side is the output. Very good. We can call this side our independent. If this side is our independent, what is this side? Dependent. Very good. What's another word we use for x? Starts with a D. Domain. Very good. Domain, and then our y value would be range. This is how we're going to refer to them from here on out, is domain and range. Okay? Last thing I want to remind you is that if we're talking about a function, then our y value can also be written as f of x. This is function notation. Well, pretty much everything's going to be written like that from now on, too. Function notation. And you say it f of x. All right. So all of this should sound very familiar so far. We're going to start with example number 1. I want to show you what it is we're looking for in a few problems today, and we'll kind of work our way through. Example number 1. All right, you're going to be given a table. Let's say, oops, that's not a very straight line. Let's try that again. It's a Monday. Not much better, but we'll go with it. All right, so let's say on top I have years, and on the bottom I have A's. I don't know. We'll just put, we'll put money. I'll take it back. We'll put money. All right, so maybe in the year 1988, we made $25 an hour. Okay? Right? In 1990, we actually went down some and made $22 an hour. In the year 2000, we made $26 an hour. And the last one, let me move this out of the way. Let's say in the year 2001, we made $25 an hour then, again. All right. So there are several things I'm going to ask you to do with this information. First thing I want you to do is we're going to make a mapping diagram. A mapping diagram shows on the left the domain and on the right the range. And they have to be written in numerical order. Okay? So we're going to start with, I like to put it in a table. This is my X and this is my Y. My domain are the top numbers in numerical order. So that's 1988, 1990, 2000, and 2001. Then I'm going to do my range on the right-hand side. And again, they go in numerical order. If a number repeats, you only write it once. Okay? So on this side, we have 22, 25, and 26. To finish our mapping diagram, we connect the dots, so to speak. So 1988 goes to 25. So from 1988, we draw a line to 25. 1990, we draw a line to 22. In 2000, we draw a line to 26. And in 2001, we draw a line to 25. This is called a mapping diagram. Okay, that's the first thing you have to do. Next thing is, for part B, I want the ordered pairs. The ordered pairs are simply your table putting your X and Y together. So in this case, my ordered pairs are going to be 1988, comma 25, 1990, comma 22, 2000, comma 26, and my last ordered pair is 2001, comma 25. Now we have one last thing to do on the same problem. So far we've done a mapping. We've put the ordered pairs together. Now I need you for part C to state the domain and range. Now when you state the domain and range, they go in numerical order and you don't repeat anything. So if you have something that's there more than once, you don't have to put it more than once. Okay, so my domain, I'm going to start with a D and a bracket. My domain is already in my mapping diagram on the left-hand side. So 1988, 1990, 2000, and 2001. Close my bracket. My range, put an R with a colon and a bracket. Again, my range is the right-hand side of my mapping diagram. So I have a 22, 25, and 26. questions? Okay. All right. Example number 2. Determine if the relation is a function. So let's say I have this beautiful mapping diagram, and maybe I've got 3, 4, 5, and 7 on this side. Is this a function? Do any of my x's repeat? No. So this would be yes. Okay? So you only have one line coming from each x. If I had something that looked like this, let's say 3, 4, and 1, 2, 7, and I have 3 goes to both of those, and 4 goes to 7, is there only one line coming from each x value? No. So this is not a function, or we can say no. Okay? Is there a question on that? You guys are doing great. Example number 3. Does the graph represent a function? Here is my first one. Here is my graph. Yes or no? If I were to draw a vertical line down in my graph, does it cross the actual graph more than once? So this is no. All right, if I have something that looks like this, how about this one? This is a yes, right? If I were to draw my vertical line down, it only crosses it in one spot. Okay, is there any question with that? Awesome. All right. Now the next section, we are all the way up to question number 9. Whew. Let's stand over here. 20. But they're easy. Yeah, they're super easy. Here's example number 4. All right, example number 4 says to evaluate. As soon as I say evaluate, what should that tell you we're going to have to do? Well, anytime we say evaluate, that means we're taking a value and putting it in. And getting out, right? When we evaluate, you take a value and put it in. So I'm going to ask you to evaluate and write as an ordered pair. So let's say I have f of x, which just means what? Y, right? I have f of x equals 3x minus 7, and I say for x equals 2. So if I'm going to evaluate, I take my 2 and plug it in for my x. You guys just told me this one means y. So it doesn't go here. This is y. So the only place I put that 2 in is for my x. So I would have 3 times 2 minus 7, which does equal negative 1. But it says to write as an ordered pair. This is my y value, right? So I have to write this as 2 comma negative 1. Let's do one more like that. Let's say I have f of x equals 1/2 x minus 3, 4, x equals negative 2. So I'm going to start by plugging negative 2 in for, put it in for x right here next to 1/2. So here, 1/2 of -2 is -1, minus 3 is -4, and then you have to write it as an ordered pair. X and then Y. Any questions here? Exactly what she had to do all the way through more 14. Just plug the number in, write it as a point. All right. Example, let's see. 5, thank you. Example 5. This is 15 and 16, excuse me, 15 and 16. Write a function rule. To model the cost of renting a car, then evaluate. So, this has 2 parts, which means it has 2 answers, okay? It's going to be listed like this. It might tell you that the daily rental is, let's say, $20, and that it costs you rate per mile, let's say, is $5. All right, and then after that, let's say miles traveled is 50. So first, we're going to use the first 2 things to write our function rule. So we have per mile, this is my rate per mile, is $5, so I'm going to have 5m plus 20. Now I can set that equal to f of x or f of m, f of whatever if I want, or just say y equals. And then we're going to evaluate. So I'm going to plug 50 in where? The m, right. So I have 5 times 50 plus 20. So for me to rent this car, it's going to cost me $270. All right? So on your homework or on the worksheet, I'm going to be looking for 2 things. I'm going to be looking for this, and then I'm going to be looking for this. So there are 2 parts. Any question there? Okay. Next. Example. Thank you. Thank you. Example 6. Yeah. Oh, yeah. Yeah. You're welcome. You're welcome. All right. On example 6, we're going to state the domain and range. Now remember that, oh goodness, domain is our x value, right? So domain is x, range is y. All right. And maybe on our graph, let's say we have an oval. We're going to pretend this looks like a really good oval, you guys, okay? Kind of looks like an oval. Domain is my x value. What's the very smallest x value I have up there? No? X values go this way, right? So all the way to the left, what's the very smallest x value I have? Right? And it's on, if my drawing was good, it's on -4. So we're going to put a bracket, -4. Now you'll notice I have x values, x values, x values all the way to here. So what's the end part of my domain? +4. Okay. Let's do the range. Correct. The range would be -2 to 2. The range always starts from the bottom, the smallest y value, and goes to the top. Okay?
So why do you use brackets and not parentheses?
Because a parenthesis means that it can't equal it, right? These are actually on the lines. They're touching them.
So if it wasn't on the line, let's say it was like 2.5, it would be a parenthesis?
Yeah, well, I mean, depending, because 2.5 they'd be equal to, right? So you could put that in there.
So like a weird random number. So like 2.
So if I had something that had an open dot, so it didn't equal it, on the actual picture, if I had, here, let me do one like this. Let's do this. Let's say I have this graph. Let's start here and go up this way, and I'm going to start here and go up this way. Yeah. No, you're fine, because I'm going to do a couple of them anyway. All right, so here's this graph. Think about the fact that those arrows are going forever this direction and forever that direction, right? So my domain here actually goes from, because this keeps going and going and going, it goes from parentheses, -infinity, to +infinity, because it goes forever that way, right? My range starts at -2. So because it's on -2, I have to have a bracket, and it goes forever up, so it goes forever where? Infinity, exactly. Okay? Is there any questions? I'm looking at the picture. You're just doing domain is left to right, range is bottom to top. Okay. All right, last thing I want to talk about, example number 7. Let's say you are given a function h of x equals 2.1x plus 4. Find the missing value for the point, let's do 3w. Okay, so w represents what? What? It represents the y value, right? And up here, what's my y value? H of x. Okay. So we need to figure out what h of x is equal to. So what do you think we're going to do with the 3?
Plug it in for x.
Yep, we're going to plug it in for x. So I have h of x equals 2.1 times 3 plus 4.
So
6.3 plus 4, or 10.3. That's actually what the w equals, right? We can also do it. Let's say I have one that looks like this. Let's say I have k, comma, 12. What would I need to solve for here? Or where does my 12 go in my function up there? Yeah, 12 is going to go in for h of x, and we're going to solve for our missing variable. So I have 12 equals 2.1x plus 4. To solve this, I would subtract 4 from both sides. So we get 8 equals 2.1x. And then what? Divide. And what do we get for my x/k value?
3.81.
Okay. All right, we'll say 3.81. Questions? Okay. Let me get you your worksheet so you guys can get going on it and get it done. And